Switching and multiplexing. Switching is a technique used to connect the communicating devices point to point in multi-device environment or network. There are three types of switching: circuit switching, message switching, packet switching. Circuit switching is connected by physical links with a dedicated channel. There are three phases in circuit switching: setup phase, data transfer phase, and termination phase. The resources need to be reserved during the setup phase. The resources remain dedicated for the entire duration of the data transfer until the teardown or termination phase. The drawbacks is efficiency is very poor in circuit switching networks because the resources are dedicated irrespective of data flow is present or not. And the best example is landline telephones. Message switching. It doesn't have a physical path which is established in networks. Each message contains addressing information and between switch they decides the transfer path of the next switch. When it's moving, first the switch reads its header and tail, and basing on the header, it finds out the address, and to respect to the address is passed to the next closest switch. And there is no dedicated path is used. Depending on network conditions, messages are transferred on different paths. Each message is stored before being transmitted to the next switch. So this is also known as store and forward switching because everywhere the switch stores and then it forwards. And the best example is email. Drawbacks. There is no limit on message size. So at every hop, the router should store them in the hard disk drive rather than memory. This makes the process slow because normally the routers they have a limited amount of memory, so they can't store a large messages. So they normally store in hard disk instead of memory or RAM. Packet switching. Data is transmitted into suitably sized blocks called packets. No resource allocation for a packet. Resources allocated only on demand on a first come, first served basis. When a packet receives a switch, it must wait until other packets being processed. Each packet is treated independently. Packets in this approach are referred as datagrams. You can see that the packets they may or may not travel in the same line. They can travel in different lines or different paths. Next, multiplexing. Multiplexing is a technique that allows the simultaneous transmission of multiple signals across a single data link. Multi means many, plexing means combining to a single output. There are three basic multiplexing techniques: frequency division multiplexing, wavelength division multiplexing, and time division multiplexing, FDM, WDM, and TDM. In frequency division multiplexing, it is an analog technique. Signals generated by each sending device modulate different carrier frequencies. And applications are AM radio, FM radio, TV channels, mobile communications, etc. They all use frequency division multiplexing. And here you can see there are three voice clear telephone channels are multiplexed using a FDM. Coming to wavelength division multiplexing. Normally, wavelength division multiplexing is used for optical signals. This is also analog multiplexing technique to combine optical signals. You can see this diagram that you have a multiplexer which is taking 1510 nanometers, 1520 nanometers, 1530 nanometers, and finally they are multiplexed, and the other side destinations are the demultiplexer it demultiplexes. And WDM is designed to use with fiber optic cable. One application of WDM is the SONET, synchronous optical network, in which multiple optical fiber lines are multiplexed and demultiplexed. And then comes the dense wavelength division multiplexing. The difference is it can multiplex a very large number of channels by spacing channels very close to one another. So it's a little bit more tighter when compared to WDM. And current system offer from 4 to 32 channels of wavelengths. The higher number of wavelengths has led to the name dense wavelength division multiplexing or DWDM. Then comes the third category, time division multiplexing. is a digital multiplexing method. The time domain is divided into several recurrent time slots of fixed length, one for each subchannel. Time-domain multiplexing comes in two basic forms: synchronous TDM, asynchronous TDM, or stat TDM. In synchronous TDM, the time slots are grouped into frames, and the frame consists of only one complete cycle of time slots, with one slot dedicated to each sending device. Means for every sending device, it allocates one slot. Empty slots. The problem with this asynchronous TDM is for every input unit, one output slot is allocated. Output slot in the frame is allocated. This is not so efficient because if a source does not have data to send, the corresponding slot in the output frame goes empty. You can see here that there are empty cells. So honestly wasting the time and space. So then came the statistical time division multiplexing or asynchronous time division multiplexing, both are same. In stat TDM, slots are dynamically allocated only when an input line has a slot's worth of data to send. Then only it is given a slot in the output frame. Means the multiplexer checks each input line in round robin fashion. It allocates a slot if the line has data to send. Otherwise, it skips the line and checks the next line. So this is the stat TDM, and there is no slot is left empty as long as there are data to be sent by an input line. If there are vacant slots, you don't allocate. Mobile telephone network. In mobile telephone network, we have various categories, and some are, one is IMTS, improved mobile telephone system. The second one is the AMS, advanced mobile phone system. This is the first generation analog system. And then came the DAM, so digital advanced mobile phone system. And then comes the GSM, as of now, which is quite popular, global system for mobile communications. So, and what is IMTS? IMTS uses a high power 200 watt transmitter with two frequencies, one for sending and one for receiving. Normally, what they do, they put this high power tower on a either on a hill or on a high place, so that it covers a large distance. So IMD supports up to 23 channels spread out from 150 MHz to 450 MHz bandwidth. Due to small number of channels, users often had to wait a long time before getting a dial tone. We have only 23 channels. That means maximum 23 people can communicate at any one time. Also, due to large power of the hilltop transmitter, adjacent systems had to be served 100 kilometers apart to avoid interference, because it's covering almost 100 kilometers. So they're very powerful transmitters. That that transmission might cause interference to the nearest other devices. All in all, the limited capacity made the system impractical. Then came AMPS, Advanced Mobile Phone System. Unlike IMT system, which uses 100 kilometers across, can have one call on each frequency. An AMP system have 100 10 kilometer cells in the same area and be able to have 10 to 15 calls on each frequency. Means the modification is, instead of covering 100 kilometers at a single time, they divide into, let us say, 10 areas, and they use 10 different transmitters. And of course, every transmitter support up to 10 to 15 calls into 10. So this became a practically a fair approach. A geographic division is divided up into cells, and each cell uses some set of frequencies not used by any of its neighbors. And frequency reuse principle. Since we know the spectrum is scarce, so you can't go on taking the spectrum. There are a lot of restrictions, as well as spectrum is also a limited range. So normally we have to reuse the frequencies which are already earlier used. Of course, they should not get interference. That's important. So this is the frequency reuse principle. The use of relative small frequencies, the use of relative small cells and the reuse of transmission frequencies in nearby cells, but not adjacent cells. You can see in this diagram. For example, you can see here there is a one, and then adjacent you want to use that same frequency. So when the reuse factor is 4, you'll get one cell gap in between the same frequency users. In case of reuse factor 7, you'll get two adjacent differences between the same cell, same frequency users. Actually, there is a principle which is given by d is equal to r square root of 3 into n. So basing on that, they can find out the reuse factor. Then comes DAMS or Digital Advanced Mobile Phone System. This is the second generation of the AM system and is fully digital. On a DAMS mobile phone, the voice signal is picked up by the microphone, is digitized and compressed. Three users can share a single frequency pair using time division multiplexing. And each frequency pair supports up to 25 frames per second of 40 milliseconds each. And each frame is divided into 6 time slots of 6.61 milliseconds each, as illustrated in this figure. You can see this figure. So it had total 40 milliseconds, and you can see 1, 2, 3, 1, 2, 3 means you can allocate three different users, 1, 2, 3. And do remember that you have to allocate one frequency allocated for upstream and one frequency allocated for downstream. So you have to allocate two, one is not sufficient. But later they modified it and they made it to use for six users at the same time. So you can see the second B diagram where one set is allocated to upstream and one set is allocated to the downstream. Then comes the GSM.